So now let's look at the horizontal stretch. So this is going to come through as multiplication with x. So again, this is inside the function. So with the horizontal shift, that was coming from addition or subtraction inside the function. With the horizontal stretch, it'll be multiplication division inside the function. So let's just kind of look at how these work, but like the horizontal shift, what we're going to see is it's going to work a bit opposite of what we expect it to do, especially after doing the vertical stretch and compression. So yeah, let's take a look at these. It's the idea that we adjust our x value first and then find the output. So what we're going to do for these, we're taking 1/2 times x. So what I need to do is find the input from my function first. So I'm going to take my x value, which in this case is -12, and multiply it by 1/2. So this is really h of -6, which is equal to 0 from over here. And h of -8 times 1/2 is -4. So we'll grab the output for -4, which is 0. H of -6 times 1/2 is -3, which isn't on our table. However, we do have our graph here. So what I'm going to do is look at x equals -3 and grab the output, which is +1. So if it's not on the table, take a look at the graph to see where it's landing. Alright, h of -4 times 1/2, so h of -2. Again, we'll go to the graph, and h of -2 is +2. H of 0, so 0 times 1/2 is just 0, so that'll just stay the same at 4. H of 2 times 1/2 is 1. And again, we don't have 1 there, but from the graph, that'll be an output of 2. 4 times 1/2 is 2. 2 has an output of 0. 8 times 1/2 is 4, which has an output of -4. And 16 times 1/2 is 8, which h of 8 is 6. Alright, so again, it's this idea that x is being cut in half. So what we're doing is we are seeing these x values kind of shrink by 1/2. They're moving inward. But what that does is then it kind of reverses effect because it takes that y value and moves it out. So where it was originally, it's now double that distance away from where it was originally. Same thing over here where x changed 4 to 2, but what that output did is it then went further away. So let's start mapping the points and see how this is coming through. So where we were at x equals -12, we have an output of 0. So what happened there is that's coming from the movement of this coordinate here, that -60 is now out at -12. So when we had vertical stretch and compression, it was this distance from the x-axis that we were increasing or decreasing. Here, it's going to be distance from the y-axis. So where we have this distance of 6, now it's this distance of 12. And then we'll have this coordinate -80, and that's coming from this change in -40. So where we had this distance of 4, now we have this distance of 8. At -6, we're at +1, -4, +2, 0, 4, 2, 2, and 4, 0, 8, -4, and 16, 6. Alright, so graphing this, we have this line across, this line up to the y-axis, down to that minimum, and then up to that maximum. So what happened here is we stretched out our graph. It's like we pulled it away from the y-axis, so we're lengthening it out across the x-axis. So it's becoming longer. So this will be a horizontal stretch of 2. So numerically, what we saw in here was a 1/2, and this is what I mean by it's a bit counterintuitive. It's working the opposite of what we're used to with the vertical stretch and compression, because what we're doing is we're just grabbing what's in the denominator there. We're using that value of 2 as our stretch. If we look at h of 4x, so what we're doing is we're multiplying our x values by 4, so this is like h of negative 48, which is not defined. H of negative 8 times 4 is negative 32, that's not defined. H of 4 times negative 6, negative 24, that's not defined. H of negative 4 times 4 is negative 16, that's not defined. H of 0, so 0 times 4 is 0, so that point's going to be staying in. H of 2 times 4, which is h of 8. So what we're doing is we're grabbing that output of positive 6. So x equals 8, grabbing that output of 6, and that is squishing towards the y-axis, and that points now at x equals 2. H of 4 times 4, which is 16, which is undefined. And then these will all be undefined too, because they'll just be too large of x values. So, with that, I really have these 2 coordinates that I can plot here. Oh, sorry, I was going to use a different color there, so I'm going to graph these in red. But really, all I got were 2 coordinates for this. I have that 0, 4, and positive 2, 6. What I can do is think about how did this point move, especially this 2, 6. That originally came from this 8, 6. So it's like in terms of distance, I had this distance of 8 away from the y-axis, and now I have this distance of 2. So what happened was our distance is compressed by a factor of 1/4. It's like we took that distance and divided it by 4. So this is making a compression. So what I can imagine for my other coordinates, like where I was at 4, negative 4, where I have this distance of 4 right here, I'm going to divide that by 4, so I would just have a distance of 1. Where I have this distance of 2 right here, divide that by 4, 1/2. So what I would get in terms of a graph is something super compressed towards the y-axis. Let's see, I have this distance of 4 right here, so now I'd have a distance of 1. So that gets super short right there. And then a distance of 6 divided by 4, so that'll be 3/2, so 1.5. So that 4 times x really squishes in the original graph. It's compressed towards that y-axis because all of those horizontal distances were divided by 4. So this does a compression by 1/4. So when we have these values multiplying with x, it's kind of like we're using the reciprocal of it. When it's a fraction, if you flip it, that'll give you how far it's going to stretch. If you have a number that's more than 1, then it's going to cause a compression by 1 over that value. Just to summarize that before we get to plugging in the negative x. So what this will come through as is a number multiplying with x. If it's a whole number or larger than 1, then what we're going to do is compress by that number. If it is a fraction, it's going to cause a stretch. And that says vertically, which is incorrect. I'll change the notes for that. That should be horizontally. All right. By a factor of that value of b. And you can just kind of think of the reciprocal of it. So we'll get some practice with those. Okay, h of negative x. What happens if our value is negative inside there? So if I just change the sign of my x values, so like this would be h of positive 12, which we don't have defined. Nope. Okay. H of 8 we have as positive 6. H of 6 isn't defined, but actually it's 1. From the graph, h of positive 4, which is negative 4. H of 0 just stays the same. And then h of negative 2, which wasn't defined, but we have it on the graph as positive 2. H of negative 4, which was 0. H of negative 8, which was undefined. And then we'll have undefined. So, if we look at this graph, what we're doing is, let's see, if I'm at x equals negative 8, my output is positive 6. So negative 8, positive 6. If I'm at negative 6, we have a positive 1. At negative 4, we're at negative 4. So what you can see is the shape of the graph starting to come through, and what happened is these coordinates reflected over the y-axis. So what we're getting is this reflection across the y-axis. So when the negative was outside the function, that made a reflection across the x-axis. But this is changing your x values from positive to negative. So if you have a negative value in there, reflect across the y-axis. We'll practice with those a bit too. Okay, so we have our original function here again. I'm going to go ahead and set up our scale here. I'll talk about the scale and what I think about with these, but it's going to depend on stretch and compression about what's going to work best. Okay, so I set up my scale here, and most of them match what we did for horizontal shift. And that just kind of spreading it out so I can see more detail with our function. The one difference is this first one here. Notice that vertically I have the scale at 2 blocks equal 1, but I didn't want to do that horizontally, and why that is because looking at this function here, which if I just rearrange things a little bit, I could see my actual factor of 1/3 times x, so I can see that value for b. And with that value, what I need to do is think about, okay, we're going to stretch, we're going to have horizontal stretch by 3. Because I'm going to focus on that denominator. It's really what's going to make it stretch out. So with that, if I'm too zoomed in on the x-axis, if I'm stretching so far, I might end up off the page. So, stretching by 3. So what I'm going to do is I'll focus on these 3 values that are on the x-axis. So 0 is going to stay exactly where it is, but here where I have this distance of 1, I'm going to do that distance times 3. So now that'll be out there. Where I have this coordinate right here at 2, 0, we're going to stretch that by 3. So instead of a distance of 2, we'll now have a distance of 6. So 2, 4, 6. And then with the peak values, you could just do, they're halfway between those values on the x-axis, so you could just use that, or you could think about the distance times 3, like this would be 1/2 times 3, so 3/2. And this would be 1.5 times 3, so you get up there. And then we're just going to connect these dots, and that'll be our function. Alright, this next one, I'm going to mix 2 pieces. Again, we do stretches and compressions first. So I'm going to take care of that -1 times x first, which is going to make us reflect across y. Now you can even read it is your x values are going to change sign. So where you had positive x values, they'll now be negative. And then this +2 on the outside, that's our vertical shift, since we're adding 2 outside of the function. So that'll tell us to move up 2. So if we go to our function here, I'm going to do the reflection first, and then the vertical shift. So first reflecting. So what I want to do is take these values and just move them across the y-axis. So this will be over here, and that 1, 0 is now -1, 0, and then we have value down there, and then we were at 2 zeros, now -2, 0, and then 0, 0 stays. So one step of it is getting the reflection across the y-axis, and then our last piece is to move up 2, and go 1, 2, 1, 2, 1, 2, sorry, lost count, 1, 2, 1, 2, 1, 2, and that'll be our final function right there. Alright, last piece here. So we can see is we're going to have 2 stretches and compressions. We're going to have a vertical one and a horizontal one. Order doesn't matter here. You can do either way. And let's do vertical first. So first, I'm going to do that multiplication of 4. So for the vertical, that's a stretch. So I'm going to stretch vertically by 4. And then for the second step, we're going to, so the 2 in multiplying with x, it's opposite of what I think, so it's a compression. So we're going to compress horizontally. And we're going to think of that as a half. Alright, so stretching vertically by 4. What I'm doing is I'm taking these y values and multiplying them by 4. So where I have this distance of 1 right here, that's going to change to a distance of 4. I'm going to get this point all the way up here. The values on the x-axis are just going to stay put, and then I have this distance here, that -1. So we're going to go 1, 2, 3, 4. So I'm going to have a point all the way down here. So I've stretched by 4, so you can see my function has lengthened vertically. So up and down, it's lengthened. Okay. Then compress horizontally by a half. So what that means is distance from the y-axis. So like I have this distance of this 1 square right here. So I'm going to cut that in half. And where I have this distance across 2 squares, there'll be half of that distance. So as you can see, this is going to squish in so close. Let's see, there's 3 squares, so that'll be 1 1/2. And then 4 squares, there. So my function, oh boy, is going to be very squished in. It's so tall and so skinny. Okay, like that. So the vertical stretch made it very long, kind of away from the x-axis. It stretched away from the x-axis, but then we have this compression of a half where it squishes it towards the y-axis.